All right, we've got 20 minutes to finish reviewing for your exam coming up here shortly. If you have any questions that didn't get answered in the video that you watched, I'll address those after we get through this other review, but I want to make sure we get through this first. Matrices, there's not going to be a whole lot with matrices on the exam, okay? Just some basic things that you would need to be able to do at a minimum on, standardized testing later on, ACT, SAT testing as you get ready to head into your senior year, things like that, okay? So if we had two matrices, one G, one N, and we wanted to evaluate 3n minus G, what would I need to do, Kendall?
You multiply 3 times the n matrix.
Good. We're simply going to multiply this by a scalar of 3, which gives us what matrix?
Negative 12, 15, negative 3, 18, 0, and 31.
There we go. And then when it says to subtract, do we ever really subtract, class?
No.
No, so really I'm going to add a negative G. So I'm just going to go through G and change all the signs. And now I'm simply adding what is now 3n and G together, now that we've added the inverse. And what do we get for that result here, Genesis?
19.
Careful.
Negative 19.
Negative 19.
18. Negative 3.
I guess there's really not such a thing as negative 0, is there?
14. Negative 8. 35.
There we go. Any questions on basic matrix operations? We're not going to get into the more involved stuff. We then talked about sequences, remember, and we said that a rule that the terms in a sequence follow, class, is called the algorithm. So here's our algorithm. We want the first 3 terms. Term 1, term 2, term 3. How would I find those 3 terms? Audrey?
You plug in.
Good. Anywhere you see the n, you plug in a 1 for the first term, class, which would give us 5. 2 times 1 is 2. 3 to the first is 3. 2 plus 3 is 5. Then we're going to plug in, class A, 2. So that's 2 times 2, and it's 3 squared, which ends up giving us 13. 4 plus 9, 13. And then the next one we would plug in a 3. So it's going to be 2 times 3, and then we're also going to have 3 to the 3rd power, which gives us 33. 6 plus 27, 33. Questions on plugging in values into an algorithm to find the terms. If I already gave you the first few terms of a sequence, you'd have to figure out the relationship. What's going on in this sequence here? Brandon?
Multiplying by 1/4.
Right, now on the surface you'd say, well, you divide by a 4, but really that's multiplying by 1/4. So multiply by a 4th to get 2/4, which is an 1/8. So if we multiply by 1/4 again, Brandon, we get 1/8. What type of sequence would this be, class, since you're multiplying? Geometric sequence, and we call this 1/4 the common ratio. The common ratio. We also had series. Remember, a series is the sum of the terms in a sequence, and we had some different formulas for consecutive squares, consecutive integers, and then constants. How do I find a series of consecutive squares? Kendall?
N times n minus 1.
Plus 1.
Plus 1. And then 2n plus 1. All over 6.
There we go. How do I find a series of consecutive integers, Genesis? Similar but smaller.
N 2n.
Help?
N plus 1.
N plus 1. So it starts off the same, it just doesn't include the 2n plus 1, and it's over 2 instead of 6. And then what's the formula for a constant series? Class? Cn. There we go. All right, so what we want to do, if you have a polynomial argument in the series, we want to split it up with the distributive property. What would that look like, Audrey?
Series of 5 I squared I equals 1. And then plus 5 times the series of I.
Not 5 times the series.
Well, the series of 5.
Series of I,
Yeah.
from 1 to 5, like that. Okay, and then
Minus the series of 5 to 1.
well,
45 times 4.
of 4. It's a series of 4, and you're going from 1 to 5. All right, so for the I squared, we're going to take n plus 1 class, and 2n plus 1, all over 6. Conveniently, so I just get 55. Then we're going to take a series of I. Well, the series of I class is,
N plus 1 over 2.
so
times 6 over 2.
we can cancel here to get a 3, so,
15.
and then here it's just c times n, it's just
Negative 20.
negative 20, and we end up getting 50. And that's the shortcut method to evaluate. Of course, you could plug in the 1, square it, plus 1 minus 4, get a number. 2 squared plus 2 minus 4. 3 squared plus 3 minus 4. 4 squared plus 4 minus 4. 5 squared plus 5 minus 4. And then add them all together. You still get 50. So it's a lot quicker to use the formula, I think. All right, questions on this stuff. This is some of the more recent material. This is this quarter now. Yes, ma'am. Yeah. Let's take a series from 1 to 7 of 3 minus 2i. First of all, I need to split it up. Genesis, how would I split this up using the distributive property?
Series of 1 to 3.
No, so a series of 3 from 1 to 7.
And then series of I and 2 on the other side.
Good, so we're going to subtract a 2 times the series of I from 1 to 7. Good. All right, so the first part is just a constant series. That's just going to be 21. But then we've got the series of I. So I got to plug that into the formula. What does that give me?
7 plus 8
Times 8
times 8 and then 15
over
2.
2. And it's times, remember, not plus. 7 times 8 over 2. But remember, we've got this negative 2 being multiplied by all of it. What's going to happen with the 2's? Or the 2 and the 8. Cancel. It's easier just to do the 2's. So we end up doing 7 times 8. And we're going to do 21 minus 56 to get, anyone?
Oh, 35.
Negative 35 would end up being our answer here. Does that make sense? All right. We then talked about finding possibilities that exist in an uncertain situation. Of course, we call that class counting. If values can be repeated, then we would simply multiply. We just multiply. If values can be repeated, for instance, Cracker Barrel has the 15 items on that, 15 sides / vegetables, right? And their veggie plate, you pick any 4. Well, if you can repeat values at your seats, find how many different veggie plates you could make. They have 15 to choose from. You're going to pick any 4, and you can repeat if you want to. That's a lot of possible veggie plates, most of which are not healthy. What do we need to do, class? 15 times 15 times 15 times 15, right? And so we simply get
50,625.
50,625 veggie plates if you can repeat which vegetable you want each time. All right, so theoretically you get 4 of the same. What if they didn't let you get any repeats? So you're just going to pick 4 of the 15 vegetables. Careful. We don't use multiplication if you can't repeat. If you can't reuse a value class, we either have to use
Permutation or combination.
combination or permutation. Does it really matter the order that we say the 4 vegetables? No, just bring you the 4 vegetables, right? In the little bowls, right? And so combination or permutation? Combination of 15 take 4. How many veggie plates if you're not allowed to repeat anything? 1,365 veggie plates, right? What if the first vegetable you name, they give you a small plate of it. Second vegetable, they give you a small bowl of it. Third vegetable, they give you the sample size bowl, and the fourth one, they give you 2 bites. Just as a little, just a sampling. What if they gave you different sizes of each portion based on the order in which you named them? Well, then I wouldn't want a combination. I want to make sure my favorite one gets mentioned first, right? So we take a permutation. How many different ways could you order the veggie plate now if changing the order makes a difference?
32,760.
A lot more ways it can go down now, isn't there? If they're giving you different sizes based on the order. Questions on when to count, just by multiplication, when to use combination, when to use permutation. Feel like you remember this? We're going to take a test over it, obviously, not too long ago. What if I said, pick a number, 1 through 10. Pick the right number, you don't have to take your exam. I'm not going to do that, but wouldn't that be awesome? All right, what if I said, pick a number 1 through 10. What is the odds that a person, just 1 to 10, picks an odd number? What is the probability of an odd number, class? 5 to 10, right? Which reduces to 1 to 2, because there are 5 odd numbers, 1, 3, 5, 7, 9, out of the 10 numbers. What's the probability that someone picks an odd number or a multiple of 4? Well, how many odd numbers are there? 5 out of 10, right? How many multiples of 4 are there between 1 and 10? 2. What are the 2 multiples of 4?
4 and 8.
4 and 8. It says or. What do we do?
Add.
Add. We're going to add the 2 to 10 to get
7 to 10.
7 to 10 for our probability here. What if, by the way, is there any overlap between a multiple of 4 and an odd number? No. Multiple of 3 and an odd number?
Yes.
Yeah, the 3 and the 9 would overlap, so we'd have to subtract any overlap there, but there's no overlap, so we don't need to worry about subtracting anything. What if I had 2 of you pick? And I said, okay, what's the probability the first person picks an even number, and then the second person picks 7, specifically? Well, what's the odds of an even number, class?
5 to 10.
5 to 10. What's the odds of picking a 7?
1 to 10.
1 out of 10. And it says, and, what do? Multiply. So now I could do a little bit of canceling here.
1 to 2.
And what's the odds that the first person picks an even number, the second person picks a 7?
1 to 20.
1 to 20. The probability there. Questions on or versus and especially. Remember, add, multiply. Questions. One selection, there's just multiple options. Multiple selections, which makes it harder to call it correctly, hence higher probability. What if I wanted these as percents, though, instead of fractions? What do I do? Put it in the calculator, right? You just do 1 divided by 2 gives you 0.5, which would be 50%. What about 7 to 10? What was that as a decimal? 0.7, so that's going to be 70%. What about 1/20th? What's that as a decimal? 0.05, so that's 5%. Okay, questions on that? Mean, median, mode, standard deviation. This was the most recent thing we talked about. Let's suppose we're looking at, this was from a couple of years ago, the Cardinals. I was tracking their runs scored in the last 8 games. At one point, they had scored 14 runs one game. It's like, yay, we're hitting really well. And obviously that means the next game they're barely going to score at all. And the next game, and the next game they get shut out. And we're like, and then 7. Okay, 7's a good number. That's a good number. And 5 isn't bad. We like that. And then 3 and 1. It just starts going downhill from there. Okay, so there's the runs scored. I want you to find the mode, the median, and the mean. The mode, the median, and the mean. And let's find the standard deviation as well. What's the mode, class?
3.
It's the only number that's repeated, so I guess it's the only one that can be the mode. Not a mode by much, granted. What's the median, class? 3. Now here's where we gotta be careful. On X bar, you do have to enter the 0 as your first value on your calculator, because otherwise it assumes it's gonna divide by 7. So if yours has n equals 7, you forgot to enter the 0 probably. What is the average, class?
4.375.
4.375 runs. What about the standard deviation?
4.470.
There we go. Notice the standard deviation is actually higher than the average. Okay, we don't have a very reliable set of statistics. Why not?
Outlier.
There's a really prominent outlier. 14 runs is not normal for this team. Okay, that's a prominent outlier. The other ones are pretty much fine. So which of these two values, the median or the mean, is the best example of what's normal for that Cardinals team?
Median.
The median is actually best, and so 3 runs a game is a little bit more common average for them. All right, questions on this? All right, were there any questions from equations that you did on the handout in our a couple lessons ago? Any questions on the handout? You watched the video, but you didn't really get a chance to ask any questions. We got just about 3 or 4 minutes left. I want to open the floor for any questions on something you did not understand from that handout. Another one bites the dust. All right.
Could we do a problem kind of like 7?
Number 7 with the radical equation? Yeah, let's take a look at number 7. We've got a 6 minus the square root of 2x plus 1 equal to the x minus 1. Remember, in a radical equation class, our first step is to isolate that radical. So that means we got to get rid of the 6. Or we're double switching the full x minus 1 with the radical. I'd rather just ditch the 6 as a negative 6 to get negative square root of 2x plus 1 equal to, class?
X minus 7.
X minus 7. Now that the radical is isolated, we want to get rid of the radical. How do you get rid of a square root? You do the opposite, you square. So we square both sides. Here the square root and the square are going to cancel, including this negative is going to cancel away, isn't it? Because a negative, when you square it, gives you a positive. So all I'm left with is 2x plus 1, the radicand. But over here, I'm squaring a binomial, 3 steps. And that's where you get x squared, positive 49, and then in the middle, a negative 14x as we multiply and double. Well, now what started out as a radical equation has become, class, a quadratic equation. So I need to set it equal to 0. So I'm going to leave the x squared where it is because it's nice and positive. I'm not going to move that. I'm going to move the 2x over, class, as a negative 2x to x squared negative 16x. And I'm also going to move over the 1 as a, to get, and it's just a matter of factoring, right? Split up the x squared into, positive sign tells me? Both sides are the same, they're both going to be negative in this case. Then how to split up a 48 to get a 16? 4 and 12, good. Not 6 and 8, but 4 and 12. I set each of these equal to 0. I get 2 possible answers for my x.
12 and 4.
Possibly 4, possibly 12, but I need to check, right? And so we come along here, we plug in the 4 because that seems easier, right? 2 times 4 plus 1, square root of 9. 6 minus 3 is equal to 4 minus 1. Plug in the 12 now. 2 times 12 plus 1, square root of 25. 5, 6 minus 5 equals 12 minus 1. No, 12 is an extraneous root. We'll only keep the 4. Does that make a little bit more sense seeing it again?
I didn't cancel the negative, so everything was messed up.
Oh, gotcha. Okay. All right. Good. Any other questions on the handout? Number 11, the system of equations. Yeah, so remember when a system has quadratic in it, normally you're not going to be able to solve by the addition method. You've got to substitute. So here on number 11, the x positive 2y equals 7. The xy negative y squared equals 4. We got to manipulate the easier equation. Which one's easier, top or bottom? Top is definitely easier. And we want to get a letter by itself. Which letter is easiest to get by itself?
X.
The x. Stay with me. So I'm going to ditch the 2y as a negative 2y. And then I can take the whole 7 minus 2y and just plop it right here where the x was. so that the bottom equation is 7 minus 2y instead of x times y minus y squared equals 4. Now from here, Audrey, what do I need to do with the parentheses to get? And I've got this other minus y squared is equal to 4. I can combine the y squareds, but I don't want it to be negative, right? So I'm going to ditch it to the other side as a 3y squared. At the same time, I can move the 7y over as a negative 7y. I'm going to leave the 4 as a positive over here, so it's all equal to 0. Because again, it turned into this quadratic. At this point, we can backwards FOIL or use the quadratic formula. This one turned out it did factor. I wasn't sure if it would or not. We got 3y and 1y. Signs are both going to be negative. And I think we put the 4 here and the 1 here to get that 7y. So my two answers for y could equal 1. That's the easy one. Add 4 divided by 3. Y could also equal 4/3. But remember, we're finding points of intersection. So one of the points has a y value of 1. The other point has a y value of 4/3. I need to figure out the x value. So I'm going to go back to this manipulated equation. If I plug in a 1, that's just 7 minus 2 class. And then I get the calculator out because it's a fraction and it's annoying. And I take 7 minus, well, let's see, do 2 times 4/3 first. 2 times 4/3. 2 and 2/3. And then do 7 minus 2 and 2/3, either in your head or on your calculator. 4 and 1/3. Or we might have had 13/3. Or we might have had 1 and 1/3. So a couple ways to express the answer there. Does that make a little more sense? Good. All right, well, we are out of time for review. We'll take a short break, and when we come back, we will take that exam. You are dismissed.